But it was fascinating to see that discussion. So we're probably, I've talked to the DHS and the Swamp project manager, and we could set up to do an OWASP meeting where we have a virtual presentation from the Swamp folks, talking about how to set it up, you know, answer questions. Looking to get into, you know, software assurance, application security, you know, without going out and buying several products to jump in. The Swamp is going to be a perfect place to start that, and maybe where even some people will live. Quickly, the OWASP chapter has got a couple initiatives now that we wanted to start to work to give back to OWASP, and we're going to start to work on cheat sheets. We've got 3 cheat sheets. Michael's starting one right now on web service testing. He's got an outline. I've got some input for him. Anybody that's interested in these other 2 cheat sheets I'll talk about, drop us an email. Say, yeah, I'd give you, a couple hours, a month or something to review and provide feedback. Maybe I can do a lot of web service testing, see where Michael's going with this cheat sheet, and provide input. And it'll eventually get published up on the OWASP cheat sheet site. The other 2 that we're looking at is 2-factor authentication, and we may even step into new user registration. So we've got the ear of some of the OWASP boards that says, you guys want to jump in? Let's go and send us drafts and start to get that going. Last item before I let Zach get going is October Cybersecurity Month. There's a number of organizations, the OWASP chapter meeting, InfraGard, there's Nebraska CERT, the Better Business Bureau has a huge presentation at the end of the month on the 23rd. And what we'll probably do is put up something up on the OWASP website to say, here's the kind of calendar that's going on of just other events to make sure everybody's aware. I think that's it for me.
Okay, it looks like the audio is broadcasting, so anybody's having trouble, it should have picked up by now. So we should be okay, so we cross our fingers. So thanks, John. One other thing, and apologize if I'm duplicating because I was paying attention to something else. Sorry, John. Do you talk about jobs? Mm-hmm. Every couple of weeks, Michael is sending out just open job postings. So if you guys want to share anything, feel free to send it to Michael and we send it out. You know, we're not trying to be headhunters or anything, but sometimes you guys hear about certain jobs that might be interesting to share with the security community in Omaha. So we're providing a mechanism to do that. So let's jump in and get started talking about some Android. We already kind of went over to our introduction, but the purpose of today is we're going to go through Android from a first-time builder perspective, and then we're going to look at that from the lens of OWASP, and then see what kind of value can we get out of looking with OWASP tools, and what can we learn in our own Android development, especially for somebody like me, who is a first-time builder. So my background is mostly I do web development. I've been doing web development since I learned what JavaScript was in like 1994 or 5, whatever it was. And I've moved through the ranks of web development from dynamic scripting to starting to get into like patterns and frameworks, and that's where my head explodes because it's all so much fun. So I kind of call myself a builder and breaker in training because I'm getting to learn these things from these guys who do it on their day job. Here, I'm a staff member, and I have a group of students that do development work for websites and apps and games and things like that. So I've got a little bit of Android exposure, but not direct work myself. So just kind of as a full disclosure, I have I have gone through and reversed an Android app as part of a class I took, our host-based vulnerability discovery, and then I also work with students to develop apps. So I have a little bit of exposure to Android stuff, so it's almost a very, very first time. So I want to talk about the actual app that I produced. So my plan was to just go through and do a little bit more than Hello World. I'm hitting Android as kind of a noob programmer. And then, like I said, go back to the mobile top 10 and kind of think, well, how bad can it get? So Hello World, obviously, if you've never done Android before, how many of you guys have done Android in some sense? Couple, okay. Setting up the environment for Android is its own feat because downloading like JDKs, downloading all these sorts of things that you have to do, it takes a little while just to get set up with it. So that aside, Hello World is a non-trivial Hello World. But I wanted to do more than that because based on my web experience, I know if I just make a web page, it's pretty boring. But if I make a web page that talks to something, that's where I get the fun. So I wanted to make sure I had internet communication, and I wanted to feel like I've learned something, right? You'll notice that I have things in red You can see it better on my screen than on the projector screen, but I have some things that are in red throughout the presentation. Every time you see a thing in red is pretty much a risk. So internet communication is a risk. The fact that I want to feel like I'm developing something is a risk. So I just wanted to pull those out. I'm not going to really call much attention to them aside from this, but to me, I thought that going back and identifying certain things that were key risks would be important and useful. Let's see here. And I don't know if my slides are actually catching up to the broadcast. So let me just take a quick cast on that. All right, we'll see if that catches up. So the tutorial I found is on a place called codelearn.org, which emphasizes more on Ruby, but this is the outline of the tutorial. Go through the basic building blocks. It's a fake Twitter app, if you will, where you have a list of tweets, a list view, a detailed view, which is a very common pattern in apps. Give me a list of things, touch it, give me the details for those things. This is what ends up coming out of it. I have a login screen, I have a list view, and then I have the detailed view. Now in these three things, as you all know, if you're programmers, it looks like nothing, but goodness gracious, there's a lot that goes on behind the scenes. So the steps through this process were actually pretty good. As I help manage my students do their software projects, we like iterative approaches, and this tutorial went through a really nice iterative approach where we went through and built a mock UI, then started adding listeners, moving things to new activities, create the list view and detail page, put a mock login in place where you store the username and password in a shared preference file, then refactor and reiterate, implementing models as a second time around instead of just random strings, adding the ability to read and write tweets to and from a file, moving code over into async. So if you've done Android development, these things are familiar to you. If you haven't done Android development, these things will become familiar to you if you ever do it. Async tasks is how you take an Android thing like fetch URL data, push it to the background so it doesn't block the main thread. It's a big no-no if you try to submit your app and you have that going on. So far, I'm feeling pretty good about the things that I'm learning in the process. When I get to the end of the tutorial, though, lesson 23 stops, and all the good stuff is tucked away in what they're calling a code challenge. If you go to the code challenge on the website, it has since expired in June. It looks like it was something to try to get people to show off their skills and then hire them by companies. So the tasks are there, but the tutorial walkthroughs are not. So I had to go and learn some things on my own, which is how you might normally do it in a job. So like logging in using Post, fetching tweets using Git. I know what those are from web programming. I don't know how to do those in Android. So I went from about 45 miles an hour during the tutorial to about 15 miles an hour while I had to go and Google everything while I'm trying to figure it out. The link to that challenge is down here at the bottom of my slides if you ever want to go check it out. The other two things that are kind of grayed out, submitting new tweets and then actually connect to real Twitter API were tasks as part of the challenge, but I did not explore those at all. This is a flowchart of what I did or how the app works. And I know the text is hard to read. Basically, open the app, display a login page, check a token, which might be stored off in a file, and look at a login API. Is it valid? Then go ahead and go to the list view or fetch tweets from cache, go to the list, select a tweet, view the tweet, and this whole cache mechanism goes out, fetches a list, looks for new tweets from the API or a database or a mock, writes the cache out to a database. So it's got a couple of components that are happening in the back end that you would expect to have for a good user interface. For example, when I open the app, while it's loading tweets from the internet, it should show something to the user. Well, really, it pulls it from the cache, displays that to the user while it's in the background going to update the contents. So again, I'm feeling like this is more of a real life application and I'm enjoying it as I go. So in the end, it works. I've got basic functionality, and now I want to go back and learn what I can learn. Learn what I can learn. There's a good one. See what I can learn using OWASP as a model to evaluate the stuff that I've done so far. So we have the OWASP mobile top 10. Has anyone seen the top 10 before from like the regular web app? Cool. The mobile top 10 is an attempt to bring the same concept over to the mobile side. Number one is pretty much go learn the web app top 10 because it's all the server-side controls. I have a slew of slides that give the summaries for each of these top 10s. You have notes in front of you if you wish to take notes. If we were to just quickly go over these, I've got the description that comes down from the OWASP wiki page. If you read these, they should be pretty straightforward as to the things that you're testing. We'll talk about some of the overlap in the end. But number 1, OWASP top 10. Number 2, insecure data storage. How are you trusting your data on the device? How are you storing and retrieving the data onto your device? What assumptions are you making? Number 3, transport. So encryption in and out of the app to other areas. Now, this mostly includes networking transport, but you could, if you wish, explore this idea of transport from app to app to app and have the same concepts. Watch out for side channel data leakage. So we're talking about the OS processes, the dev framework you might be using, any sort of analytics or social tools that might be integrated into your app. If you're trying to be secure, in super air quotes, do those things open up exposures that you might not be thinking about? URL caching, copy and paste, the clipboard, for example. Number 5, poor authorization and authentication. So this one, the main point here was just because you're on mobile and you're trying to make things cool for the user, don't make it less secure than a browser, right? So if you have fewer factors on mobile than you do on the browser, something might be wrong in your implementation, or at least your thoughts of your architecture. You can always, if client-side authentications can sometimes lead to client-side bypass, which you get in a web application. If you're using a cookie to store tokens and somebody can manipulate the cookie, right? That's what this one is talking about. OWASP suggests never to store credentials on the device, avoid 4-digit pins, and then give consumer opt-in for persistent authentication, not just keeping things local by default. Number 6, broken crypto. This is the one that keeps the NSA guys up, right? If you try to build your own algorithm of encryption, you might want to come and take a class at UNO, plug, because this is the, what does it say, trivial at best when you're bypassing built-in encryption algorithms, but then that quote in the middle there comes from the documentation. There's no easier way to mishandle than to try to make your own algorithms and protocols. So this means if you're not familiar with hashing and how to do back and forth, like verification, Bob and Alice kind of stuff, you might want to go back and review that before you implement your own. And then, of course, poor key management. Client-side injection. Just like in web applications, we have injection possibilities at the SQL database side of things. Input validation. You also are adding in the layer of views and client-side components. For example, if you have web pages in your app, to make it easier to develop, you might have a whole lot of injection issues and cross-site scripting as part of your static web page content that's built into your app. So watch out for those. Number 8, security decisions via input. This one was a new one for me, and maybe you guys have seen this before, but the idea here is that you're making security decisions based on something from the user. Now, maybe that's, well, here we have. Maybe it's coming like you're allowing a user to paste in content. You're allowing a user to do some sort of URL connection. URL schemes. Have you got anyone familiar with that? It's where you have like, you use a URL to open an app. So like mail app, ; // blah, 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 blah. I guess a URI would be the better term. You know, if you're using one of those, make sure that whoever is mapped to your intent for that URL is clean and known. This one has limited data on the wiki though. So if you know things about this, it would be a good place to go and help OWASP. Improper session handling. This goes back to web as well. Watch out for poor authentication. It has the same risks and effects as poor authentication. Common failures, lack of timeouts, invalidating sessions, and then also even, when you log into the web application, you want to give a new session token. If you change privileges, you want to give a new session token. So watch out for those transitions. And then lack of binary protection. This one to me is one of the more fun areas, but it's on the bottom of the list. I'm not sure how they quantified the list, but reversing the binary, watching the, checking out the methods of class, looking for strings, presentation layer attacks like we talked about. Can I get into your app's HTML folder and do something with the JavaScript or CSS, and then runtime analysis and injection stuff. So with those as the background, we're going to take a look at 5 in detail. These 5 are the ones that when I went through that list, I could actually take some action even on my demo app. So we're going to go through these in detail. Number 1, which is number 2, insecure data storage. A little background. Well, this is the summary. This is the point. Copy. A little background. If you know anything about Android, you know that it's a Linux-based operating system. So it has the same kind of permissions on files and data. So everything has a user group and other. like Chmod code for Linux. The apps are installed with a specific user and group, which is unique to the app, or at least that's what I've seen so far. If you have physical access, using the Android debug bridge, you're able to do a whole lot more than you might not expect your users to be able to do. You can take the APK file, you can watch it as it communicates, you can use the ADB command to pull a copy off out of a protected file space, because you can tell ADB to run as the app. So you tell ADB, run as the app in which I'm trying to get access, copy that file as me out to a world writable space, and now I have easy access to pull down a shared preference file or a cookies file, things like that. And then permissions and shell, you can ADB over to the shell of your Android device and just, ls, give me the files, explore. So what does that look like when you're thinking about it? There are 5 different ways to do storage on Android. You have a shared preferences file, which is essentially a key value pair. You have internal file storage, like private data in memory and files on disk. You have an external file storage, public data. So those would be things like the documents folder in Android or the pictures folder in Android. You have private databases, and you have network communications. This list comes from the Android guide online. If we take a look at the shared preferences file, this is the one that I found most fun when I took that class and did some reversing to figure out. I was asking a question about an app that I downloaded that goes along with my home cloud, I call it, where you can access your files from your phone kind of deal. Well, shared preferences is simply a file. It's not anything special. When you use shared preferences in building an Android app, which is a very common thing in tutorials and the one that I found, the data is loaded in that location. So /data/data app, whatever the app name is, shared prefs, and then the name of your collection.xml. It's in plain text. So if you're using shared preferences to store out usernames or tokens, it's in plain text. Combine that with Android's file system security, and you've got some risks. Luckily, the default mode is private. Luckily, sure. If we look, this is what I was talking about with the file system permissions down here. We have read, write, and then the user is this generic user that the system built for my app, code-learn twitter.xml. Well, what does that actually look like? Here's the code that I've got to write it. Very simple. It's a name-value pair where I have a couple of lines of code, because it's Java, to grab my shared preferences, write the shared preferences out to a file, and we're done. Well, if we look at the file, this is what's actually in it. So the saved username value is plain text Zach. I'm not doing any sort of checking in the top lines of my code. I'm not doing any sort of encryption on storage. Whatever the user typed in this case, it's in there. Now, I didn't test XML injection at this point. I suppose that you could if the user types something in XML-y, and you could try to see if it injects, but I didn't. So that's fun. So back to that app I talked about, this is a real-life app that a company made where I expected them, I was curious, how bad can it get? Well, taking a look in their app, they were actually storing my username and password in plain text so that they could make HTTP basic authentication calls back to a web service. So when I opened up the app and looked in the XML file, my username and password was stored right in their shared preferences file. You might say, oh, well, it's protected because it's private file, whatever. But if we go back, we're making an assumption about local data storage that maybe we shouldn't be making, because that shared preferences file is so commonly used as an option, named value pairs. It's just storing it out there in plain text. So watch out for that. That's for sure. They were using HTTPS, but yeah.
Basic auth over HTTP doesn't get that.
Yeah, basic auth over HTTPS, but basic auth. And they're storing their credentials locally so that they could pass it to their proxy service that they had. So then as a developer, I'm thinking, oh, what else can I do? Wouldn't it be great to have two apps access the same shared preferences file so that way I can store one token in one app and then use it in another? Well, maybe. You can override the defaults where you can make a shared preferences file globally readable and globally writable, but that's horrible. And starting in Android API 17, it's deprecated. You don't want to do it anymore. But really, there's another object and another pattern to follow in Android, and that would be the content provider. That lets you do that. The other four, or next three, are file storage. You're going to have the same issues with local file storage, whether it's a SQL database, internal, external. You have to have some sort of expectation of trust in the file, or you have to assume that you have no expectation of trust. If you're going to encrypt your data and encrypt it in the file, make sure you're doing good encryption. On the external storage, you have to watch out for media availability checks. So if your app depends on the SD card or data that was stored by user preference to the SD card, you better make sure it's still there, or your app might have some problems. For network-based storage, check out point M3, cloud storage concerns, because all those kind of apply. That takes number 2. Now, along the way, if you guys have questions or things you want to add, please do. I would, if you can ask me a question so I can repeat it for the folks that are watching online, that would be useful too. Moving on to transport layer protection. This is the second one that I thought was useful in my demo app. The question that I had, being somebody that has done this before, is, am I really vulnerable? Back in undergrad, I did some SSL research and learning. I know about the 3 types of checks for certificates, matching the algorithm, you have the name match on the cert, you have the date, you have the CA chain, all those things. Am I vulnerable in any of these points? Weak handshake, personally identifiable information to endpoints via non-secure channels, which jeopardizes secure data. That one's a new one for me. When you signed up for a service, you may have received a code or maybe even a password over a text message. That's an insecure way to pass data. So if your app has a requirement to stay on a secure channel, but you're using a text message or an MMS or an email or even a notification service, you're not using a secure channel anymore. You have multi-factor and you have out-of-bound communication, but if you're sending something that could be, sniffed or watched that you consider sensitive, don't forget that those outbound channels are not encrypted, or at least not that I'm aware of. Okay, so watch out for those as you're doing that. John?
One other thing to think about is your SSL termination point the same as your applications point? Okay, so I may be, because of the infrastructure, I may be hitting an F5, which is handling all of my corporate SSL termination, but the F5 isn't serving my application. So now I'm further into the network, how far, where I've got now PII data that's no longer being encrypted.
Yeah.
And another best practice too now is just to avoid the CA chain altogether and certificate, and meaning hard code your certificate information directly in your app, so that it makes it nearly impossible to man in the middle of it unless someone's got root and unlocked access to the phone, where they can uninstall and have to bypass the checks during ones. But hard coding the certificate information is the best practice.
Cool. So hard coding certificate information, best practice for the apps. So in my breaker in training question, what happens to the data if I do attempt to sniff it over a proxy? Will the application that I built accept the invalid certificate, or will it crash and burn? I just don't know, because I didn't make any special code. I didn't put any code to handle certificate in my app. So I pulled up OWASP, proxied it up for my device, which is way easier than I remembered it being, but it works great. Zap was running on my local computer, and then I told my phone over the Wi-Fi to hit my computer's IP address, etc. If I were to do the regular login on my app that I built, it goes over clear text. The data is being sent, no big deal there. But if I change my URL endpoint in my application just to an HTTPS, and I did already verify that the HerokuApp.com did have the certificate set up with the right name and everything. What happens? Well, I have a gold star of awesome, because by default, the app will crash, or at least throw an exception. I guess my app didn't crash, it threw an exception. So typing in the same credentials, the exception got handled, and you can kind of read certificate path validator exception, yada, 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 and I get my login failed. Way cool. Now, what made that work so easily without knowing about it was the object that I used to make the connection. If we look at some details of some legacy objects that weren't there, you could find them in tutorials or in older versions of Android. The URL connection object, the HTTPS URL connection, and the Android HTTP will all throw exceptions if certificate checks fail. However, if you've got some code that's using the Apache HTTP client, or you're trying to do SSL plus some other protocol like mail or FTP or something. When you're using the SSL sockets or the HTTP client, it has a couple of caveats that will not fail properly unless you code for it. So in this example, if you've ever set up name-based virtual hosts, you know that the name is part of the encrypted packet, so the server has to decrypt it first, et cetera, et cetera, et cetera. The older versions of Android and HTTP client does not support that name-based convention for SSL certificates. Then the sockets here, it does not perform the hostname validation by default, which kind of makes sense because you're dealing with it at a socket level rather than host name. But if you're not accounting for those things, or at least aware of those things, you got to watch out. Starting in Android 4.2, this is something that I thought would have happened earlier, but only in Android 4.2 do the CA lists come down in a dynamic way. Otherwise, they're hard-coded in the OS at the whatever version it came out as. This came because I was curious, and I read the guide page, and then I learned all these things. Go OWASP. Were you going to add something to that one, Michael?
Yeah, so typically when you're testing an Android app, you have to tell the device to trust your proxy certificate in order to successfully proxy them.
Right. So that fail was on purpose because if I wanted to sniff with the HTTPS, then I would have my device trust that certificate. Yeah, Robin?
So like on a browser, is there a way to sort of put in an explicit exception in the app?
Yes.
Are there functions that allow you to do that, or is it always?
Well, you can catch the exception. The exceptions are class-based exceptions. So you could throw a catch for that particular exception and then program the UI to tell your user, hey, this is freaking out and here's why. But by default, it will throw the exception if you're not handling it. At least it's not going to just allow the invalid certificate chain.
Allow, okay, so
Nope.
you won't allow.
Yep. Yep, it won't allow it unless you're using one of these older objects that can do the connections. All right, so moving on to unintended data leakage. This one, Michael, thank you very much. Came from you, partially. So the idea is the more side channel leakage from the OS itself, a dev framework, analytics or social tools. You can see on the right-hand side, this is one example of some data leakage. So again, depending on the classification of your app, you have things to consider that aren't just within your app. If we take a look at this, we see that my screenshot of the app is in place, which might be fine. But what if I don't want people to see my screenshot? Apparently, there's a quick way to do that. If in Android, I want to hide the screenshot from showing during that recent apps list, 2 lines of code, I tell the window in the applications on create or the activities on create to hide itself. Thank you, Android. So where might this come into play? Some of you might recognize this mobile app. This is a banking app. I wonder if this banking app is built with an HTML base, but if I were to have this open, I've blocked out my account numbers and all that sort of jazz, you could see those. Now, let me help them out a little bit. They don't have the full account number in view. My balance is in view, my name is in view, an XXX account number is in view. But if you're allowing like corporate data to go out on an Android device and you're going to show some sort of identifiers, just like you would for an SSN, you don't give people access to view it, or if they have to view it, you're going to watch the OS caching and how they even make screenshots when switching in and out of the app. So, yes, sir.
Explicit screenshots.
Didn't get into that. But at least for the recent list, that was something that I didn't think of till one of Michael's presentations. So I thought I would call it out here, and there's an easy way to prevent that from happening. Screenshots themselves, I didn't look into that. Anybody know that one off the top of your head? Can your app prevent screenshots, or can it just detect screenshots?
When I said static screenshot, right?
Yeah, like
I want my screenshot to show.
power button down key on my Android.
Yeah, what I see a lot of people doing is just flashing a full white or black image over the actual.
To protect against a screenshot. So when it detects a screenshot, it black or white. That's a good idea.
Or,
Okay, so this kind of comes into 3 areas that in my head. Things that you do control or can control are the app's behavior and how it has some interactions with the system when it comes to leaking data. Things you don't really control are some of the internal system things like garbage collection and caching. You might have some influence on those, But in the case of strings, for example, I read an article on this about how strings, when they're declared as final, they're in memory kind of forever. So if you're using a string for storing passwords, that might be in memory for a long time compared to like a character array in Java, right? So there are some other things to think about depending on how crazy you want to make yourself. And then, of course, there are things you wish you could control, which would be users, out-of-band stuff, and then the internets. Yes, sir?
And ADB allows you to dump it in memory into a readable file.
Yeah.
I mean, the biggest one is you don't put sensitive data.
Don't put sensitive data on the device. Yeah.
Even if you're not saying things encrypted, like Logcat, part of the ADB will send all that order cryptic statements, so you're debugging live, that Logcat can see all that.
Yeah. If somebody can get to your app, you're pretty much hosed because they could take it down and try to deconstruct the binary and at least debug it, which is,
Well, keep in mind, ADB needs to be run on a rooted device.
it doesn't need to run on a rooted device,
Now,
but who has an Android with a rooted device?
The crutch of thinking just because I'm running in a mobile iron or some type of mobile management environment, that this would never be rooted. That some of the apps and some of those like mobile iron will come up and not let apps run if it's on a rooted device.
Well, the emulator too, there's restrictions for that as well, the emulator, but once it can be Logcat.
Yeah. All right. Well, I'm gonna keep on moving through. Those are good tips, guys. Number 5, poor authentication and authorization. There's really not much that I did on this one aside from, oh yeah, I need to do more than this when I'm checking my token, right? You want to make sure that you're actually validating your token, making sure if you're storing it out to a file, the format's coming back from the file in the right format. That's an easy one, but it's also an easy one to forget about if you're putting a lot of trust in, oh, well, if they logged in, they should have the token, right? So
Does this token live forever?
does it live forever? All those sorts of things. Is it valid? Is it still issued? Can you go back and check your server to say, am I still valid? And then don't forget, if you're checking the server, that what happens if you fail out of the server? Something that came in my web learning is, I don't know if it is still the case, but PHP on Apache doesn't really care what your session identifier is. So if you give it a random one, it will create a session for you. Whereas IIS or some of the other servers, they will reject ones that they haven't created themselves, or that the server hasn't created themselves. Kind of the same thing here. If you're checking your token and your server is just allowing the random string being used, you maybe could do some checks to make sure it was issued to begin with. So that was just a reminder. And then M9 also relates to this, which we'll get to. I guess we won't really get to it, but just session handling. Client-side injection. There wasn't a whole lot that I could do in the demo app that I built. A lot of you know about injection because of some web stuff you've done or just data input validation, but something that I came across, which I thought was really interesting, was a tool that comes with Android called Monkey. Has anyone ever heard of this or seen this? Okay. It allows you to just flood your app with random inputs, so fuzzing, and it gives just a shell. You specify the package name and then the number of things to do. I will give you a pro tip. Do not reverse the P and the V. It is order dependent. What happened was I said ADB shell monkey -v 5000. And what that did is it did 5,000 random inputs on my whole device. It didn't restrict them to my app in particular. So my language settings got modified a little bit, so I had to go back to fix that. So make sure you put the package name first, because that will restrict the scope of the inputs to the package name. Pro tip. And if this link works, hopefully we can get a quick, I have the video of what it looks like. Go, go, go. Here we go. And we're going to jump into about part way because I didn't learn how to make the video work. Yeah, so when you load Monkey up, it'll open up your app and it'll just start bombarding it with random inputs. And it is using like the Android classes for inputs, so you don't have to specify field names or menu names or anything. It will just randomly go through up, down, left, right, keyboard.
Part of Android?
Part of the Android toolkit. There's a whole bunch of tools that come down with the SDK. Yes, sir.
Provide credentials so that you go in and do it.
Yeah, there's a whole lot of command line switches that I didn't really play with, but if you can pass it in something, kind of like your Apache and curl tools, you can provide some credentials. All right. Oh, hey, look, there it is. So there are a whole bunch of developer tools for doing app kind of like benchmark testing that you can go through. The Monkey is a tool. There's a Monkey Runner, which is a Python engine that lets you script a series of Monkey stuff, which you could use that for integration testing or really just testing before you release it kind of deal. And you can even have Monkey talk to device, like say you had 10 devices plugged into your machine, you can have it go across all 10 devices and everything. So it's kind of a neat tool. The last thing to kind of talk on was lack of binary protections, which, you know, if you've done this, it's kind of fun and easy. You grab an APK, you pull it down, you can reverse it and see all the goodies. ProGuard is the answer that a lot of people just go to. Like Google, both Eclipse and Android Studio IDEs will enable you to use ProGuard. ProGuard is a tool that obfuscates your code. It will go through your classes and your files and just rename everything and make it cool. The process of reversing, regardless of if you do ProGuard, is as easy as 1, 2, 3, and this is what you get. I've got a full list of all the classes that I have in my application and the full source code. Pretty darn cool. If I were to run my app through ProGuard as an obfuscator, what it does is it just minifies many of the class names and then tries to resolve strings from like a global object down into where it's being used. And you can see kind of on the left here, we've got A, B, A, B, A, B, A, B, and it does all the mapping internally. There are some config quirks that you need to go through if you set up ProGuard to make sure that if you're using dynamic activity creation, you are naming it. You're like putting it on a whitelist kind of deal. So, and then also putting in third-party libraries. Luckily in my app, I didn't have to do any of that. It just worked, so we're good to go. One of the things that ProGuard does not defend against, though, is strings. So back in that consumer level app, this is an example of something I found in the app. The fact that the user and password show up tells me two things. One, it exists. There is a username and password being used somewhere in the device. The other thing is that this is not just the name of the field. Because it's a keyword, that means that this is being used to access something somewhere else. So that leaves me, or this is actually the backwards path, after I thought about it, the fact that they were using the shared preferences file is why this is not resolved out to something else, right? Because in my shared preferences file, I have a hard-coded key name for each of my values. Well, that has to be kept somewhere, so I can't obfuscate that. So this means that, hey, if I were to find strings in my app, it means, hey, there's probably something that's important that's getting stored out somewhere else that needs to be hard-coded. So it was just another smell to say that there's something going on here. If I were to look at the app I actually built, this is what it looked like ahead of time. Async, fetch tweets, login, read, refresh, etc. And I've got code. You see, I've got hopefully well-organized code. When I run it through ProGuard, it obfuscates the main classes that are not activities. Activities stayed there. And then it took, I had a static class that just held strings for me, and it basically resolved all those to be putting the strings in the place that they're being used. So there's not a whole lot of action that I would take here aside from running it and being aware of how it works and how it might affect especially strings that I have stored in my application. Adding on to that, Google does have some protections for the APKs. If you've noticed recently, when you load it, if you ever try to do this, you load an app from an untrusted source, Google will pop up and tell you, hey, do you want Google to inspect your app to see if it's cool? And you say agree or ignore or something. Google Play has services that will help you check for valid apps. But the suggestions from Google and the Android team are these 4 elements. Use ProGuard first of all. Use your key by constructing it from several places, and really that's just mitigating the strings attack. Use bit manipulation to try to hide keys again, and then assume the key isn't secret, but you don't want to make it easy. So Michael's got a good tip in there then. You know, if you're going to need to store something on the device that needs to be safe, some sort of public-private key encryption is probably a good way to do it, but you're going to be having to deal with, you know, do you have a shared public key that's out there? that's going to open it up anyway? Do you do per user kind of combination with hash codes or something? And that's beyond my expertise and knowledge. These guys can probably tell you more about that.
Another interesting tool to use that some of this doesn't prevent is if I'm going to take an app and beat up on it, I'm going to be using Eclipse's memory analyzer. Okay, so now I've got it running in there. I can go into memory analyzer and start to look for my string objects and start to interrogate those. So you've still got, once this is great protection for the APK, and it may be the best that you can get, but keep in mind that there's other things that I've got the code, I'm running it.
Yeah.
I can bring the APK down to my simulator, my environment, and run it there. And I can go and, if you haven't looked at the memory analyzer in Eclipse, it's great for a lot of things, but it's really cool here.
Yeah.
There is no magic bullet.
Yeah, I mean, you're giving users your full code base because it's in Java and everything. So don't write applications. That's your answer. Don't write them. Okay. So those were the 5 ones that gave me actionable steps that I could take even for my basic steps. So I wanted to go back and review, what did this give me by going through this exercise? How did the top 10 fare? As a tool to better my own security mindsets, I learned a lot about Android. I had a lot of digging to do, and I went to a lot of resource pages. So doing the app and then combining it with OWASP gave me a focused lens to look at the security of what I've done. It did refresh some of my web concepts with like how SSL is working down and with the TLS 1.0 and the virtual host names and everything. So I got a little refresher. And that even though there's no silver bullet, there are some basic steps that get us pretty far, assuming we've implemented them properly. Also, I've got some new concepts in my tool belt now that I wasn't quite aware of with like the shared preferences and all these sort of things. Some drawbacks to the top 10 themselves, in my opinion. They do have a big reliance on the flagship top 10 of OWASP, right? This is only dealing with client-side application. You can apply these to iOS as well as Android or Windows Phone. I did Android, but that server-side component where your data actually is being communicated to the central repository of data, that's a big deal. So number 1 is go learn the web app top 10 if you don't know it. The second thing is that some of those points, like the session manipulation and the token or authentication, those things, I feel like they overlap a lot. So as far as applications for what to do about it in your job, there's a lot of gray area on if you need to define these requirements map to M3 or M6 and M9. And I think that's usual, but it was just something that, as I was writing the slides, well, which part goes to which part? There's some overlap. The other thing is that the wiki itself is not quite complete. There are some pieces missing for number 8, for example. So if you have expertise in these areas, it's a wiki. Share the love. They have some metrics on each of the points. They're not that helpful, to be honest, because they all are marked. There's a couple of columns I took out, but attack vectors, weakness prevalence, weakness detectability, technical impact, and then there's 2 on either side that talk about the application-specific and business-specific impacts, which they all said app-specific. But if you look, all of them are rated as easy exploitability on the website right now. Weakness detectability, they're all rated easy except for 1. Number 6 and number 10, if we're thinking about how can we detect bad crypto, I don't know if I would call that easy. How can we detect bad binary protections? As a programmer, again, I don't know how I would call that easy. So maybe there needs to be some love for the 2015 version. If you have expertise in this area, contribute back to OWASP, or at least maybe throw some suggestions back. Because according to this chart, every attack vector is basically easy. The prevalence of them are common. The technical impact is very severe. So this would make me not ever want to tell somebody to build an app, right? And that's obviously not a really good answer, because that's where,
To touch on where Zach's talking about contributing back, all the projects will have a set of authors up there in the OWASP. So you can go to the top 10 mobile and go up to the wiki page up there, and it'll say who's the authors, like Jack Medina. If you don't feel comfortable talking directly to Jack, send emails to us, and we'll help get the introduction going so that you can talk to them.
OWASP is a very friendly group I found from going to Denver. So there's really no big deal. Hey, Jack, let me help you out. I wouldn't start by saying you're wrong, but maybe let's help you out. I have some ideas. All right, so this is a matrix from the website. If I were to go back to the list, these are the things that by going through the list, I was able to identify and then take action on my app. So 2, 3, 4, 5, 6, but those specifically, I went back into the shared preferences. I made sure I'm not storing username and password, which was part of this tutorial to give them credit, but that was something I did. It's always storing the token now. The transport layer, I was able to test what happens if I'm getting a man-in-the-middle attack, or at least my chain fails. Okay, the app doesn't let somebody in and share the password. Okay, we're good there. Number 4, okay, it's trivial, but I could remove the screenshot off the recent list. And number 10, running it through ProGuard, it doesn't protect me completely, but it does make it harder for somebody to go through my app and understand the logic of what's happening. More experiences, just kind of based on stuff we have going on here at the college. As a developer myself and manager of some of these student projects, the things that I see are dependencies on transport layer. Just, hey, it's SSL, it's TLS, we're good. You know, you probably hear that in your business. Crypto secrets being stored in the app, mostly because a lot of my students just don't know how to do something better, right? So we're working through that. Oversimplified authentication and authorization. You saw that with if token is not null. Little to no protections on file data. For web programmers, we rarely have to worry about that because up until recently, there was no client-side file data outside of cookies, right? Now there's local databases and everything. So that was that one we don't usually deal with here, but we're working on that. And then some binary protections, some misunderstandings of ProGuard itself and how to use it. And then also we have a lot of assumed protections right now because, oh, it's iOS. You can't reverse that unless you had a jailbroken phone and you talk to somebody like Michael, right? So in my own experience, these are some pressure points or some vulnerabilities that we have to watch out for. Also, trust in the API itself. What kind of things do you guys see in your own environments? Are there things in particular that you see, Michael?
Exported components on Android.
Exported components, can you dive that a little bit deeper?
Yeah, so Android allows you to export certain functionality of your app to other apps. So let's say you've got a password storage app that allows you to take intent for activation from other apps like email or something else that requires a password in order to quickly and functionally store it in your password storage app. If you don't require authentication for some of the functionality, the authentication piece may be bypassed by making an explicit intent to activate directly to the functionality instead of first to the authentication screen to get into the app and unlock the database. Content providers, which are the components that interact with SQL databases on mobile phones, again, if you're not careful to protect the URIs, for instance, if you properly protect a URI that doesn't end with a trailing slash, but fail to protect the URI that does end with a trailing slash, that second one is going to allow somebody to get directly into the database and try to make SQL queries into your SQL database. So again, very specifically protecting with read-only access, both forms of URIs, if you do have to export your components. Things like that.
If I were to take that over to the web world, to me, that's kind of like saying, if I've got, for example, PHP files, which could be directly accessed by URL, that don't go back and assume or check authentication,
Right.
then we're screwed. So those sub-activities or those sub-actions need to make sure they go back through your authentication component.
Yeah, or you protect, say, the fully capitalized main version of the file and not the lowercase name version, right?
Oh, yeah, so, okay.
Example.
All right, cool, thank you. Some other resources from OWASP and just out there, there's a Goat Droid project, which is, you can, I didn't get a chance to do this, but you can go and download a vulnerable application and kind of poke around and explore. Also, of course, the cheat sheets, you've probably heard a lot about those from us. We're actually helping out on some of those, we're trying to. Then the OWASP Top 10 by itself. That brings us to the end of what I had to talk about. Any questions? Thoughts, concerns? We'll have the slides posted and the video posted shortly, and I haven't, but I suppose I can make the code repo available if you guys want to poke at the code I built and laugh at me because it's my first one. That would work. That's fine. Okay, anything else?
So does anybody think about this too, and either now or drop us an email if you have some topics you'd like us to explore for presentations? You know, do you just want a presentation? Do you want to get into where we take some of the tools again, like Zap, and bring those up? You know, and go through some in-depth things like that to say, I've heard you say Zap, I've played with it, having a little trouble with it. You know, we're easily open to spending time to get into doing those type of things.
Cool. Did you ever talk about?
Yeah, we're gonna actually, I think I started the conversation going with DHS and the Swamp folks, the project manager, and they've offered to do a virtual one, so we just need to find a time and put it together. And we'll put up some of the information up on Swamp on the website. It's a very interesting endeavor there.
Yeah. Now, did you already talk about Nebraska CERT?
Yes.
Okay, cool. So that's it. That concludes our meeting today. If you want some CPE, or at least be able to account for it, make sure you sign our sheet that's there. And then again, the colleges have asked that you sign the pizza sheet, if you will. Grab some pizza on the way out. Feel free to stick around, ask some questions, and have a great day. Thank you.